Let's think of them as a machine that takes an input, performs one or more mathematical operations on the input, and produces an output. So you're taking a few friends out for a
Now, earlier it had volume with it. So.
Understand how functions work. Let's think of them as a machine that takes an input, performs one or more mathematical operations on the input, and produces an output. So you're taking a few friends out for a buffet lunch that costs $7.50 per person. The rule for this function is that the total cost is equal to $7.50 times the total number of friends going to lunch plus 1. You're going to eat 2, right? Let's turn on the function machine and input a few values to see what lunch might cost. Any value we input into the function machine is transformed by the mathematical operation or the rule of the function. So what if no friends come to lunch? The output is going to be $7.50 because you're still eating. What if 3 friends come to lunch? What if 5 friends come to lunch? Now, let's find the cost of 8 friends coming to lunch. But hold on now, you forgot to include the tip. Let's say that 4 friends are attending the lunch, and let's leave a $6 tip. Now we need to change the rule of our function to $7.50 times n plus 1 plus 6. Let's find out our total cost for lunch.
Functions, you're going to be looking at you're going to be coming up with a lot of rules. Part of ours.
All right, the total cost for lunch is going to be $43.50. Input, mathematical operation, output. That's how functions work.
So this next one, is kind of funny, but you know, just so you don't have to have lots of comments.
Why do you do this to us?
was a lot. Quiet, the rest of you. And green. So maybe green. Just everyone can think what the answer is without saying it out loud. Just think it quietly in your head, not out loud. That's true. That's what you're thinking, right? Quiet, please. You're not making sounds. You're just watching. Just picture yourself in a movie theater. Don't make comments. So in that one, the cows came in, the cows came out, right? We look at our function machine, right? I don't know that this is true for spam. This is kind of a parody on it. It's always coming out with a 6. So these are special kinds of and I know you can predict it in your head, not out loud. I know. Now we're trying to think. Don't say it again. Just wait. The rule is what? So, when we are looking at, I thought it was kind of a funny one. I hope none of you were too offended.
Kind of more of our cannibal.
I'm really sorry, but
That was amazing.
kind of fun. So, if we are looking at your notes, because I want to get you started, what's due for Tuesdays when we take our test. So as we look at this next vocabulary, this lesson B1 that you're doing is not due until Wednesday. A function is a special relationship between two numbers. It pairs each input with exactly one output. So they give us some different examples in that video in both videos of which ones were functions, right? They put them in that function machine. It says functions can be displayed different ways, such as tables, lists, graphs, equations, and mapping diagrams. Independent. If you think of that when you're graphing in science or in math, that's your X. So our input is usually our X. Please, no more singing. I know it's that tune is stuck in your head, but that's all right. No more right now. This is called our domain. So when we talk about what's the domain, we're talking about your input values. We're talking about the independent variable. Yeah. I know it. I know it. You guys, I have the assignments up for you and the video, and you guys will just be able to do that, and we'll miss you. The output is our range. Nothing. He's talking about next week, Wednesday, on the bus trip. The people that are gone, everything's up there for you to do. It's already posted. So range is our dependent variable. Range is all of your Y points when we are talking about those. So when we talk about a dependent variable, the Y usually depends on the X. X is independent. You get to choose it. The Y is your dependent variable. So we'll talk a lot about domain and range. You saw it in that video of what those were, so making sure you're looking at those. So then it says, when you're given a list of ordered pairs, a good way to determine if something is a function is using a mapping diagram. Step 1, list the numbers in the domain in one column. So what I'll have you do on the first few ones, we'll write the word domain, and then the next column over, we'll write the word range. So then we're just going to take from our list, and you're just going to put down, -2 was 0.5, 0 was 2.5, 4 was 6.5, and 5 went to 2.5. So anytime you're looking at that ordered pair, the X is the domain, the Y is the range. So our X is the domain, the Y is your range, okay? And you notice that in this one, we did not write 2.5 twice. If that number repeats itself in either the domain or range, you only write it once. The question is each input giving us one unique output? This one does. Every input gives me one output. This is a function. Whereas when we look at B and we put our domain, so they put 4, they put them in numeric order. Do you have to have them in numeric order? No, you could have put 6 first. 6 goes to 5. You have 4 goes to 3, you have 5 goes to 8, and then you have 6 goes to both 4 and to 5. Because 6 maps to 2 different things, this is not a function. You can have 2 things go to the same. We saw that with the Y equaled 6 in the video. Everything that was input, we always got 6 out. Didn't matter what the number is. That's a function. This one is not a function because when you put in 6, one time you get 4, and the next time you get 5. It has to be unique. It has to be, each input has one output. So the top of the next page, we talk about the vertical line test. The vertical line test is whenever you're given a graph, the quickest, easiest way to determine if something is a function is using what's called the vertical line test. You'll use this in algebra, you'll use it in Algebra 2, you'll use it in your advanced math classes. Vertical line test simply says this: if you draw a vertical line anywhere on your coordinate plane and it only passes through one point on the graph, it is a function. If the vertical line passes through more than one point, anytime it passes through more than one point, it will not be a function. So when we are plotting these points, so they plotted the point -4, 2, they plotted the point -3, 1, they plotted 0, -2, -4, -1, they plotted all of those points. And if we plot all of those points, then we are, thank you, then we are looking at if we draw a vertical line. So they drew all these vertical lines, and here it crossed 2 points. If you would have made that domain and range table and mapped it, you would have also seen this, okay? In this one, so this one is not a function. The second one is a function. The reason it is a function is because everywhere where I draw a vertical line, it only goes through one point, okay? So, as you are looking at that next part down in your notes, it says determine if the relation is a function by drawing a mapping diagram or using the vertical line test. Vertical line test is for the bottom three. On the top, I want you to write the word domain and range for each one. And we are going to be filling in our domain. So if I'm filling in the domain, I'm going to start with 4.2. What does 4.2 map to on my range? 1.5. Then I have 5, and it maps to 2.2. And then I have 7, and it maps to 4.8. And then I have 4.2, and it maps to 0. It's a function, right?
Yeah.
Why not?
Because it
Oh, and when I do this and I set it up, what I would actually do is I definitely do not want to write 4.2 twice, right? I do not want to have this 4.2 because I already had 4.2 here. So you do not ever want to write it twice, but now you want to show 4.2 will give us 1.5 or it will give us 0, okay? 4.2 gives us 1.5 or 4.2 gives us 0. So is it a function? Not a function, right? The reason it is not is that 4.2 gives us 2 different outputs or ranges. So what you're going to look at right now is on your own, and you can check with the people sitting by you. You want to come up to the front? So what you're going to take a look at is do the domain and range for the next one, and then the vertical line test. And put down if you think it's a function, but I do want you to list your domain and range here. I don't care if you use circles or you use boxes, however you do that, but show that. Go. So check with your shoulder partner if we're looking at it. Right? Phil, go back and do the first one.
This
You
one
didn't do it.
failed.
Okay? So if we are looking at that first one and I'm looking at my domain and range, I should have, was that second one going to be a function? Is this one going to be a function? Each input gives us an output, okay? Each input was giving us exactly one output, right? On the bottom, the vertical line test. Maria, first one, does it work? Is it a function? Does the vertical line go through more than one point? Okay, so the question is this. When I draw a vertical line, does it go through this red line, does it go through more than one point? So this goes through how many points on that red line? Just one right here, right? And if I draw this line, it goes through one. And if I draw this line, it goes through just one. Each vertical line only goes through one. The rule says, to pass the vertical line test, if you draw a vertical line anywhere, gentlemen, knock it off, and it passes through one point on the graph only, it's a function. If it passes through more than one point, it is not a function. So the first one should have been a function. This is the equation like we did in the video, y equals 2. Every input you put, you're always going to get an output of 2. Doesn't matter what you input. That is a horizontal line. That is a function. This one should be, if we are looking at it, non-function, right? Same with the last one. The last one is not a function because when I look here, like this went through one point here and then it went through the point up here. Like it goes through 2 points. Even though someone says, yeah, but right here it only goes through 1. But if you draw it anywhere in that function that they graph, if it doesn't work, if it goes through 2 points, if it goes through 2, then it is not a function, okay? So, please take a look at this input-output table. So we're going to be looking at rules, okay? So you have to come up with your rules. When we look at this one, does it first, if this is our domain, please write domain up here, right? Domain, really our x, that's what we're talking about. This is our y coordinate when we graph, or our range. Does it represent a function? Does each input give us one output? Yes. If it is a function, what is our rule? So, looking at making the rule right now with your shoulder partner, think about what is the rule for this one, and you can do that right now. Just kind of come up with a line that's wrong, and we're going to talk about the difference of a discrete graph and a continuous graph. So in this one, this is our table. Each input, if you were looking at the rule, Keegan and Mason, what would you say the rule was? Y equals 2x. Someone said, can I put y equals, or the output equals x times 2. We're usually going to put the coefficient, the 2 first, but could you say the output equals twice the input? Yes, that would work also. Usually we're going to get in the equation like this. This one is discrete at this point because we are just losing these points. So those of you that drew lines, go back and plot the exact points. 0, 0, 1, 2, 2, 4. Why is it discrete? This might be something like if you're going to buy granola bars, right? You cannot go into the store and say, hey, you know what, I take 1.5 granola bars, right? I want 1.5 boxes of granola bars, or I want 1.5 donuts, right? You either buy a donut or you don't buy a donut, right? So discrete graphs are just going to have dots, okay? You will see that. Continuous ones are going to have a number, we'll have a line with them, okay? So if something's continuous, a lot of times we'll see a line, whereas discrete will just be the points. So, right now, with your shoulder partner, come up with the rules for each of these tables, okay? All right, if we are looking at this, I see most of you have 2, 3, or 4 of them done. Notice it doesn't give you a 0 points that you're working with when we did slope-intercept last year. That's okay. What is our rule? Y is equal to x plus 4, right? If we're looking at some of our other rules, this one we are looking at taking and subtracting 14. Do you agree?
Yep.
The next one on the bottom, if we are looking at,
6x.
we should be multiplying our x to get the y. And quiet, please. In our last one, I would take it any of these ways. X divided by 3. I'd have it this way. I also had someone say, can I do 1/3 x? That is the same as this one, right? This is like a 1 in front of x. So this is kind of 1/3 x. Okay, good. So when we are looking at this, this is going to be the key part to your homework. There's one more page in your notes that you're filling in. So when we are looking at this, good. It says, quiet please. Will runs 6 laps more than and Megan joins him at the track. They run together at the same pace. The relationship between the number of laps that they each run is a function. So let's make our table of values. Megan has run 0 laps. She gets there. Will has run 6. Once she has a lap, he's run 7. So fill in the rest of your table. Let's go up to 5. Just fill in your table.
I can't fit 5.
So, if we go to graph it, right? 0, 6 is the point here. Plot the points, please. 1, 7, 2, 8, 3, 9, 4, 10, and we can continue. Our equation. Check with your shoulder partner and try and write an equation for this. Okay. So I heard some of you like, oh, first I don't get it, and then I'll go, oh yeah, it's as easy as y equals, yes, x plus 6. Okay. Should this be continuous or discrete? Continuous. You can run a half a lap, right, on the track. You can run a 4th. So this one should be continuous. This one should be a line. Because the information we're given, it is going to be a line. Now, as you are working on your homework, I need you to make, when you do this, the mapping. I need you to put the word domain, and I need you to write the word range. And I need you to show me how you map it, and then you're going to tell me if it's a function or not. So I still need to see this mapping. I will tell you that if you're still not getting that vertical line test, I'm going to have to move back then. So if we are looking at that vertical line test, go back and look at the definition in your notes if you need to, okay? So it is these 2 pages. This should not be hard for you to get done for Wednesday. Some of your